Okay, one of the last videos about naming things. So we see here that we've moved on to naming covalent compounds, right? And I've made a note up here that's pretty important. It says we are only going to name binary compounds in the covalent family. So binary means that it will only ever have two elements, right? No polys going on here, just two elements. So we'll go and look at these examples that I've written down over there in a second, but we know that we're going to only have two elements, and we know that because we've used the word covalent, that we're going to expect both elements to be non-metals. Right? We need to go find the non-metals on the periodic table. So the non-metals on the periodic table, we know, are over here, just on top of the metalloid stairs. Right? There are not very many nonmetals, which is why naming covalent compounds is quite easy, particularly because these inert noble gases, right? Noble gases here have a great electron configuration. They're not looking to get electrons or lose electrons, so they actually do not participate very frequently in in covalent bonding. So we are not going to learn how to name things that have noble gases in them. So we're only going to name covalent compounds that are comprised of these few non-metal elements. So we just have to know that they live over here. If we see in our list of things we need to name, if we see that there's nitrogen and hydrogen, hydrogen or oxygen, anything that we might want to see in our periodic table, we'll see that they're all nonmetals and they have to come from this little corner. Or, I always forget about hydrogen, hydrogen's hanging out over here. For the purpose of figuring out if he's covalent, we can imagine that he actually has a little home where he sits over here next to helium sometimes. So we'll allow him to sit in our minds right here so that he can be included in this non-metal corner. Okay, so that's where the non-metals are, and we're going to need to always remember that when we're looking at these things that we're trying to name. So I'm going to teach you the rules. They're really quite straightforward, far more simple than ionic stuff. If you look at something and you believe you have a binary covalent compound, such as in this case where we have nitrogen and hydrogen, all we need to do is learn some we need to learn some Greek prefixes. Okay, so we've got to learn these Greek prefixes. I'll make a list here for you. They're also in your book. The Greek prefixes are how we're going to name covalent compounds. So if there is a 1 somewhere in your formula, you're going to use the prefix mono. If there's 2, it's di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. And 10 is deca. Okay, so as soon as you identify something as being covalent, meaning it's comprised of two nonmetals, then you're going to use this list of Greek prefixes. If you see a subscript that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the subscripts will have the numbers from the formula, and when you come up with the name, you're going to use the prefix. Okay, so subscripts to prefix, prefix to subscripts. These are the rules that we have to learn. It's really not that bad. Okay, so if we look over here, I see that I have nitrogen and hydrogen, both nonmetals, right? So the way that naming works in the covalent system is very similar to the way that the naming and spelling works in the ionic system. The first element gets the full name, nitrogen. The second element gets the same spelling change as we've learned in the ionic system. So I'm going to keep the first syllable, right? So I keep high, and then I add IDE. So this is actually hydride, right? So I drop the rest of hydrogen, and I add IDE. So I have nitrogen hydride. But I said we're going to look at the subscripts, 2 and 4, and we're going to add in the prefixes. So the prefixes will be for nitrogen, I see 2, so I'm going to call this dinitrogen. And for hydride, I see 4, so I'm going to use tetra. So I have dinitrogen tetrahydride. And that's the name, right? If I had more room, I would have spelled it right out there. But that's the name, and you write it down in 2 words. Dinitrogen's the first word, tetrahydride's the second word, and that's all there is to it. Okay, so let's practice H2O. So for H2O, we can go and find our nonmetals. All right, I got hydrogen, I got oxygen. Now hydrogen's in front, right? And we said the first element gets the full name. So if hydrogen's in front, we call it hydrogen. Oxygen's in the back, we're going to say oxygen, except we have to do our spelling change. So we keep the first syllable, and then we make it oxide. Okay, so now I've got to go back and capture my prefixes. So when I see the subscripts in the formula, I can come up with the matching prefix for the word. So I see 2, I call this di. I see a 1, right? Well, I don't see a 1, it's implied. There's no number, it's a little 1, so I'm going to use mono. So that would be dihydrogen monoxide. Now there's this weird little caveat that we have to catch here. The systematic name for naming these, they do not like OO or AO to be touching in the middle of the word. It just adds an unnecessary syllable. So we do not go for OO or AO somewhere in the middle of the name. If we see that happening, so obviously this is mostly of concern for oxygen or oxide on the end, right? We don't want that happening for the oxide, so we just cancel out the vowel from the prefix. So this would not be monooxide, this is just going to be monoxide. So if I were to write the full name here, I would come up with dihydrogen monoxide. It's really not that tricky. There are no charges, there's no neutralization, nobody's crisscrossing, right? I just say the element that I have, either the full name and then a spelling change, and then I use the prefixes to represent these subscripts. So the 2 becomes a di, the 4 becomes a tetra, the 2 becomes a di, the 1 becomes a mono. And that's how I come up with these names. We just have to watch out for this one spelling moment. Okay, so if we use those same rules and just went back the other way, right? The tri, I know, tells me how many of the phosphorus I must have. So now the prefixes are going to take me back to my subscripts. So I have triphosphorus. I'm going to put the P for phosphorus, and I know that it's got a 3 because it says that I have 3 of my phosphorus. Chloride tells me that I have chlorine on the end, and the penta tells me that I have 5. So I put the symbol and the subscript, and that's it. That's not so crazy, right? So it's better than ionic. Okay, so let's do a few more because there's some idiosyncrasies I want to show you about this. So let me grab some of this and start deleting it. Okay. So let's take a look at this compound, CO. We've mentioned this compound before in class, right? We've maybe seen it before. It has some health concerns, and it's sort of a popular compound. So if I follow the rules that I've just set up for us, I would call this mono, because I see a 1, right? Or there's an implied 1 on the carbon. I'd call it monocarbon monoxide. Now I know it's not monooxide because we said that spelling change has to happen. We don't want OO or AO in the middle of a word, so we'll call it monoxide, right? But I think that we know that this is actually just carbon monoxide, right? If we saw this written out somewhere, and we have in an earlier video, and I think we talked about it in class, this would be carbon monoxide. So one of our rules here isn't working out. Right? There's one other little glitch in the naming system. Besides the spelling concern in a monooxide, that's one of the little things we have to watch out for. The only other idiosyncrasy in this naming structure is that if the 1 is on the first element, we don't say it. We do say it if it's on the second, right? If it's on the second element, we say mono or whatever we're allowed according to spelling conventions. But if it's on the first one, we don't say it. So if I was going to come up with a name for this compound, right, I would see that that's carbon. This is chlorine. I couldn't put the mono there, right? The rule says no mono if the one is on the first element. So we would call this carbon tetrachloride. Likewise, if we were going back the other way and we saw something written like sulfur dioxide, let's say dinitride, because we've been using oxygen a lot just for fun. We'll say dinitride, right? There is no prefix here, so I don't know how many sulfur there are. So that's why we have to be aware of the rule that if there is no prefix on the first element, then it's an implied 1, right? There's a little 1 here. So we're going to call this S, and we know that there's just one of them. I see that there are 2 nitrides, so I would say SN2. So sulfur dinitride would have a formula of SN2. Those are all the rules. You just have to have an idea about what subscripts correspond with what Greek prefixes. Weird that I called them fixes, prefixes. And that's all you have to do in order to name these. So I'll put up a couple practice problems and then we'll go over them in class. But the most important thing is that you can differentiate covalent things from ionic things so you know which naming system to be functioning in. So practice some of those extra ones and we'll go over them again in class on Thursday.